about the decimals and how to work with decimals. Remember, it's important to understand decimal values, especially when it comes to money. And now we're going to be working with our fraction values. And I know a lot of people get panicked or overwhelmed when they think of fractions. But fractions, if you know how to work a problem out with regular whole numbers, then you can work a problem out with fractions. It's the same concept. It just follows a fraction rule. And the nice thing is you guys have these calculators that do fractions for you. You have fraction buttons right on here, okay? In fact, everybody turn on your calculator, and if you don't have a calculator, go get one right now. Remember, grab your desk numbers calculator. So the fraction button N over D, located here, if you press that in your screen, it's going to give you a flashing box on top. Then you've got a fraction bar, and you have another box on the bottom. These little arrows off to the right help you navigate through the problems. So if you go up and down, it'll help you go to the top and the bottom of the fraction. If you hit to the right all the way, then it's going to get you out of the fraction. These are important things to note. So what I want you to do right now in your calculator, go ahead and type in the fraction. Let's do 3 on the top, and we'll do 8 on the bottom. And then I want you to get out of the fraction. So you should have 3 over 8, and then you should be out of the fraction. Does everybody see that on their screen now? Okay. Now, what I want you to do is down here at the bottom, right above where it says enter, you see the double arrow? They're right back there. Here. See the double arrow white button? I want you to press that. And if you look on your screen, you should now have the double arrows written there. Go ahead and hit enter and tell me, what does it do? It gives you the decimal version. So if you hit enter, it gives you the decimal version of that fraction. Gives you the decimal version. So this is a good friend of yours. Because if you don't remember how to convert your fractions into decimals, this will help you. You can type your fraction in, you can hit that, and it'll convert it. Same thing with a decimal. I could type in the value 0.65, and I can hit that double arrow. So I have 0.65 with the double arrow, and hit enter, and it converts it to a fraction. And now here's an even nicer thing. Let's say that we've got the fraction 8 over 16. Is that simplified, 8 over 16? Yes or no? No. 8 over 16 is not simplified. I could still simplify it, but instead of me having to think, how do I simplify it? If I just hit enter, it simplifies it for me. So this is going to be very beneficial for you when you're doing your fraction operations. All you are going to have to remember is operational words. So if it says, what's the difference between these two fractions? You're going to subtract those two fractions. If it says, oh, her hair length was 15 2/3 inches long, but then she got a haircut and took off 3 2/4 inches. How long is her hair now? She gets a haircut. What operation is that? Subtraction. So you don't have to worry about subtracting the fractions because you just have to worry about what the operation is. Once you know the operation, you use your fraction buttons. So fraction button, again, is the N over D. Now, what if it was a mixed number? If it's a mixed number, see how we all have that button that's green that says second? Hit that second button and then hit the fraction button. And notice you now have it populating with a box in the very front and then fraction boxes. That lets you do a mixed number. So I could type 6 and then I have to scroll over and maybe I'll do 4 and then I'm going to scroll down and maybe I'll type a 9. and then scroll to the right. So now I have 6 4/9 typed into my calculator. Okay, if I want to know it as a decimal, I'm going to do my little double arrow and hit enter, and there it is, 6.4, and the 4 is repeating. So this is a very useful tool to have. This is why I say it's so important for you guys to have one at home, because if you don't have one at home, then you're not going to have these functions. Yes. Go plug it in over there and then go back to your seat. Okay, so what we're going to do today with our lesson, now that we have our calculators and we know how to navigate them, and again, guys, the only way you're going to get good at this is just to use it over and over and over again. By the time the school year is done, you will know exactly how to use all the functions on here, okay? And then it'll be useful because you can use the same exact calculator again next year. All right, so we're comparing. We're doing which one's less than, which one's greater than, is it equal to? So we've got 7/10 compared to 3/5. It is easy. The easiest way to compare fractions is just to convert them to decimals. If you can convert it to a decimal and compare it in decimal form, it makes it that much simpler. So let's go ahead and type into our calculator. I want you to type in 7/10. Then hit your double white arrows and enter. What do we get? 0.7. So right below here, I'm going to write 0.7. 0.7. Now, I want you to do the same thing for 3/5. Go ahead and type 3/5 into your calculator. Do 3 fraction 5. And then your double arrows and enter, and you get 0.6. So if we're comparing those, is 0.7 less than, greater than, or equal to? It's greater than, right? 0.7 is greater than 0.6. So we're going to go ahead and put a greater than symbol. That means 7/10 is greater than 3/5. Okay, we're going to do the same thing for here. We have a negative 1/3. So we're going to type in a negative 1/3. So I'll have a negative and then my fraction. Type your negative first, then type your fraction button. I'm going to put 1/3. Get out of your fraction. You need to make sure you're out of the fraction, that it's no longer cursor flashing inside of it. Then you hit the double arrows and enter. And we get negative 0.3333333. It's all those threes. It means it's repeating. So we're going to write down negative 0.333. I'm just going to write to the thousandth place value. I'm estimating. I'll put my little bar at the top because I know it's going to keep repeating. That's called bar notation. Okay, and then we're going to convert this one. Do negative 3/4. Negative and then 3/4. Raise your hand when you've got that conversion written down. Angel? So your negative sign is down here at the bottom. Your negative sign is in white. Your subtraction sign is in the black. So you'd hit your negative sign first, then your fraction. Jolie, what did you get? Negative 0.75. Okay, so what we're going to do is we're going to compare first. We both have negatives. They both have 0. Then the next number, one of them's a 3 and one of them is a 7. So which one is smaller? Negative 3 or negative 7? Negative 7. Negative 7 is smaller than negative 3. Negative 7 is smaller than negative 3. Remember, negative numbers are the opposite of positive. So what you would normally know as your smaller number now becomes your bigger number for negatives. Okay, so that means that the negative 3 repeated is going to be greater than the negative 0.75. All right, problem number 3, we have a mixed number and we have a decimal that we're comparing. Mixed number and decimal. So if we convert 1 and 1/2, you probably don't even need to type that into your calculator. Guys, what is 1 1/2? 1.5, right? We can do 1.5, but we're comparing it to 1.4 5, 6. Now, I had a student one year who says, well, when I see that I've got 3 numbers behind the decimal on one of them, I like to make sure my other one has 3 numbers as well. How can I make this have 3 numbers? What can I put here? 0. Very good. We can add as many zeros as we want. It doesn't change it as long as it's in the back. As long as it's behind the decimal in the back, it doesn't matter. So now we're comparing, okay, they both are 1 point, right? 1 point something. But this one is 1.500 versus 1.456. Which one is greater? 500, right? So all of these happen to have greater than signs. Okay. Now, here's the part that gets people confused all the time. It's the identifying fractions on a number line. So obviously, each of these lines are not one whole, right? We have a 0, then we have a whole bunch of lines, and then we get to one whole. So these are fraction values in between. Fill in the information. I only put my signature. Okay? So each of these lines represents some fractional value. So when you are creating that fractional value, here's what you should do. Count. Count how many lines it takes you to get from 0 to one whole. Let's count it. Starting at 0, we move 1, 2, 3, 4, 5, 6. It takes us 6 lines to get to one whole. That means each one of these has a denominator, a bottom value of 6. So what I want you to do is I want you to write underneath each of them a fraction bar and a 6 underneath it. Now, once I get to the one whole, I don't have to write a fraction bar anymore. Now, our numerator is just going to be in order. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. Where's 6, 6? One whole. Okay, and what do you think I'm going to do here? After the one whole, what do you think is going to happen here? Daniel? It's going to be another 6, right? 1, 6. It's going to be another 1, 6. It repeats. 1, 6, 2, 6, 3, 6, 4, 6. And it just keeps going. And the same thing in reverse, backwards, but now it's negatives. Negative 1, 6, negative 2, 6, negative 3, 6, negative 4, 6, negative 5, 6. And then negative 6 over 6 is just one whole. And then repeats again, negative 1, 6, negative 2, 6, negative 3, 6, negative 4, 6, and it just keeps going and going. So now when I'm trying to identify the values for these letters, I have all the fractions written out. So let's start with the letter A. The letter A is at the value negative 3, 6. However, it's also past that value of negative 1, right? So anything past this point, let me go ahead and write this point. Anything past this point is going to be written as a negative 1 and some fraction over 6. Anything past this negative 1 point is going to be written as negative 1 for the whole number and then a fraction based off of something over 6. So in this case, point A, which is located right here, is going to be a negative 1 and 3/6. Negative 1 and 3/6. Now, we can always simplify that. Okay, we can always simplify that. So A in simplest form is negative 1 and 1/2. Okay, anything between the 0 and the -1 is going to have no whole number. These are not mixed numbers, no mixed numbers. Because they haven't gotten to that 1 whole mark yet. They haven't gotten to that 1 whole mark yet. So let's take a look at problem B. Problem B is located right here. Since there is no mixed number portion, it's just going to be equal to that fraction. What is the fraction? -2/6. Now, of course, we would always want to type it in the calculator to see if it can simplify, which it could. It becomes -1/3. Okay, anything between 0 and this point right here is also no mixed numbers because we haven't gotten to a whole number yet. So anything between 0 and 1 whole is not going to have any mixed number form because there is no whole numbers. So let's take a look at point C. Point C is what value? What value is point C, guys? 3/6. And again, we will type it into the calculator to check to see if it can be simplified, which it does, to 1/2. Now, point D is past the 1 whole mark here. It's past that 1 whole mark. So that means point D is going to have a mixed number. It's going to have a mixed number with 1 whole and then a fraction with the denominator being a 6. You're going to have some kind of number up at the top and a fraction of 6. So we know D is going to have that 1 whole, and it's going to be here at 4/6. So it's 1 and 4/6. But we always want to simplify it. It simplifies to 1 and 2/3. The important thing is to first get what fraction value you're dealing with. Because is the number line always going to be split up into values of 6, 1/6, 2/6, 3/6? Is it always going to be that? No. Because if we look at the next one down here, we don't have 6 numbers or 6 lines between the 0 and the 1. Our number line is spanned out even further. Okay, and we have less tally marks in between. So that means that we're dealing with a different fractional value. We're going to be dealing with a different fractional value there. So for here, with this second problem, like I said, these were all split into fractions of 6, okay, because of the fact that there were 6 lines it takes you to get from 0 to the 1. Let's count how much it takes us to get from 0 to 1 here. If we go 1, 2, 3, it takes us 3 spots to get from 0 to 1. 1, 2, 3. So that means that each of these are going to have a denominator of a 3. So I'm going to have a 1/3 and a 2/3. 3/3 is just going to be 1 whole. Then I've got 1/3 and 2/3. 3/3 is then going to bring me to the 2 whole. Then 1/3, 2/3. And we keep on filling that in. Obviously, anything to the left of 0 is going to be the negatives. So we'll have -1/3, -2/3, -1. Then we have a -1/3, -2/3, and then -2. Then we've got negative 1/3, negative 2/3, and then we'll have a whole number of negative 3. Okay, so that means each of these is split into different segments. All of the values ranging from here, from -1, all the way to +1, all of these values are going to have no whole number, right? They are not a mixed number. These are no mixed numbers. That means that they have no whole number value to them. They are just the fraction itself. Anything ranging between 1 and a 2, all of this stuff ranging between a 1 and a 2 is going to have a mixed number of a 1 and then some value over 3. And same thing for the reverse of it, going from the -1 to a -2. All of those values are going to have a mixed number of -1 and some value over 3. What about the values between 2 and 3? What about these values that are ranging between 2 and 3? So from the 2 mark to the 3 mark, what kind of mixed number or whole number value are they going to have? What whole number value are they going to have if it's greater than 2 but less than 3? A -2 over here and a +2 on this side. So these ones are going to have a mixed number portion of 2 and then some number over 3. This one's going to have it as a -2 and some number over 3. Okay? So it's just showing you how they split. So let's go ahead and focus on each of the specific points here. Point A is located at this mark. It's in between the -1 and the -2. So that means it has a whole number of that -1. And what's the fraction of it? Look at the problem. Look at where A is. What fraction value is it? We already know the whole number is -1. What's the fraction going to be? 2 over 3. The fraction is going to be 2 over 3. So we have -1 and 2/3 for this problem. All right, problem B. Problem B, there is no mixed number, so we don't have a whole number portion. We just have the fraction. What is the fraction going to be for problem B? Take a look at it. It's already been plotted there for you guys. You just have to tell me what it is. What is the fraction of problem B? Kyle? -1/3. Okay, problem C. Problem C is greater than 1 whole but less than 2. So it has a whole number. It has a whole number of a 1. But it has a fraction of what? Look at C. Where's C at? What is the fraction? Malia, look at where C is. What fraction is C at? It's right up here on the board, honey. Look at where C is. 1/3. So we have 1 and 1/3. And then problem D. Problem D, I didn't put down here what this is going to be, but it's past the 3 mark. So what is the whole number going to be if it's past the 3 mark? Daniel? 3. And it's at 3 and 1/3. So there's all of our fractions for here. I want you guys to try this bottom line on your own. Before you start telling me what they are labeled, what the A, B, C, D is, I want you to first find out what is the fraction going to be. What do each of these little tally marks represent as a fraction? So remember, you start at 0 and you count how many spots it takes you to land on 1. That tells you the denominator. So go ahead and fill that in first. So because each of these, there was a jump of a fifth, 5 jumps, that means all of the values underneath the fraction are going to be a 5 underneath. So again, -1/5, -2/5, -3/5, -4/5, and then another whole brings us to that -2. Okay, so now when I'm trying to plot them, I need to see what am I passing. So for point A, we're going to do point A right here. I'm going to highlight it so it stands out as a brighter pink. For point A, we start at 0. We passed one whole. Did we pass the -2? Look at it. Did we pass -2? No. So we are between -1 and -2. If we are between -1 and -2, then we have a whole number of -1. We passed the -1. I got to write that -1 down. I did not pass the -2, so my whole number is just going to stay a -1. What is the fraction going to be? 2/5. So there is point A. Point A is at -1 and 2/5. Okay, point B. All right, I went past 0. Did I pass -1? Yes or no, guys? Did we pass -1? No. Point B did not go past -1. So is there going to be a whole number? No, there's not going to be a whole number. So we're going to go ahead and just identify the point. What is point B at? -1/5. -1/5. There was no whole number that it passed. Point C. Does point C go past a whole number? No. Point C did not go past a whole number. So what is point C's value going to be? Say it louder, George. 4/5. Okay, point D. Does point D pass a whole value? Yes. What whole value did it pass? It passed a 1. Point D passes the whole value of a 1. So we know that point D is going to have a 1 and what? 3/5. Only way that you're ever going to get good at it is by practicing over and over and over again. Okay? Azariah, head up, honey. You have to just look at it and go, okay, all right, I passed this point. I passed the next point. I passed that next point. Same thing that we did up here with problem D. Problem D, not only did it pass 1, it passed 2, and it passed 3. That's why our whole number was a 3. Because once it passes that point, that becomes its whole number. Okay? Go ahead and go to the page in the back. The next page. I want you to try that problem. Try working through that problem. Identify what the fractional value is going to be first. Then you're going to identify what each of these letters represents. Identify the fraction value first, then identify what each letter is going to be. And don't forget, check inside your calculator to see if it will simplify. Okay, Ian, tell me what marking are each of these markings going to represent? What fraction? How many jumps does it take you, Ian, to get from 0 to 1? 10. So then each marking is a tenth. So if you know how many jumps it takes you, that's what each marking represents, guys. It's a tenth. That means here, I'm going to zoom in so we can see it a little easier here on this side. From starting at 0, going to the next tally mark, that is 1/10. The next one is 2/10. 3 over 10, 4 over 10, 5 over 10, 6 over 10, 7 over 10, 8 over 10, 9 over 10. And then we don't have to write 10 over 10 because that's just one whole. So this marking right here brings us to one whole. Okay? Going behind it, working in the reverse, they're still 1/10 and 2/10 and 3/10, but they're negatives now. So we're going to have negative 1/10, negative 2/10, negative 3/10, negative 4/10, negative 5/10, negative 6/10, negative 7/10, negative 8/10, negative 9/10, and then again, one whole. So right at this mark, we're at a negative 1. And then it keeps going again in the reverse. Some more. So we have negative 1/10, negative 2/10, and so on and so forth until we filled it all up and we've gotten to the last marking, which is at the negative 2 mark. So as long as we know what we're filling in for our fractions, and I know it's real hard to write small, but that's what you're putting in there, all those negatives. We get to that last marking here. That last marking is at negative 2. We have it all filled out. Now we can figure out our points. So let's focus on point A. Let's focus on point A first. Point A is located at this dot. Okay, what point did I pass? What big point did I pass? Daniel? Huh? The negative 1. I passed the negative 1. Did I pass negative 2, guys? No. So can I have a whole number of negative 2 here? No. So A is going to have a whole number of negative 1. And then what is the fraction going to be? What is the fraction for A going to be, George? 9/10. So we get negative 1 and 9/10. There's our fraction for here. Okay, let's look at B. Azariah, for problem B, let's take a look. You can either look on yours or you can look on mine. For problem B, did we pass a whole number, Azariah? We're located right here. No. At no point did we pass a whole number. So we will not have a whole number for our fraction. We will not have a whole number because we never passed a whole number here. So, Azariah, what is the fraction going to be for B? Negative 5/10. Now, type that into your calculator. Double check. Can we simplify negative 5/10, Emmy? What can it simplify? 1/2. So I'm going to write negative 5/10 right here. But when I simplify it, I'm going to write down that B, this is simplified. It becomes a negative 1/2. When it's simplified, it becomes negative 1/2. We always want to check to see if we can simplify those fractions. Simplest form is important. Okay, let's look at C. Let's look at C. So C is located right here. Eileen, did we pass a one whole mark? No, we did not pass a whole mark, so we're not going to have a whole number. What fraction is C at? 1/10. Is that simplified? Yes. So I'm going to go ahead and write down C is 1/10. Okay, let's go to our last one. D. D is located right here. D. William, did we pass a whole number mark for D? No, so we will not have a whole number value for D. What fraction value is D? Not 10/10. Well, what fraction is this at? 8/10. Can 8 over 10 be simplified, guys? Yes. So I'm going to write down, yes, this is technically equal to 8/10, but we are going to go ahead and simplify it. And Jeremy, what is it when it's simplified? 4 over 5. Very good. Okay, so at first it can be confusing, but when you practice it over and over and over again, it gets better. It gets easier. Okay? All right, we're going to number these values in their order. We're going to put them in order from least to greatest. Now, in order to put them in order from least to greatest, we need to have them all in the same format. Okay, we need to have them all either written as fractions or they all need to be written as decimals. They can't be a mix of two. Which one did we say was easier for comparison, fractions or decimals? Decimals. So let's go ahead and convert everything into either a whole number value or a decimal value. And guys, technically, every single number is an imaginary decimal. If you look at the very back of the board, right behind you in the back of the room, you see a bulletin board that says Invisible Math. The very first top pink sheet up there says 6 is also equal to 6 point what? 0. Every number can be written as a decimal if you add a 0 behind it. If you just do 0.0, you can change every number into a decimal. Okay? So now 2 to the third power. 2 to the third power is just the same thing as saying 2 times 2 times 2. What is 2 times 2 times 2, guys? 8. Okay? So this value is 8 or 8.0. I'm going to go ahead and put 8.0 because I know that I'm going to have some decimals. Okay, 1.8 or negative 1.8 is already in decimal form, so I can just leave it as negative 1.8. And now here I've got negative 1.85. So they're trying to trick me now. They're adding a second decimal, so I'm going to go ahead and add a second decimal behind each of these. I'm going to add some imaginary zeros behind those. I'm going to add some imaginary zeros behind those. All right, 4. 4 is a whole number, so we're just going to go ahead and write it as 4.00. 2 and 4, 6. Go ahead and type into your calculator. Remember, 2 and 4, 6. We are going to type it as a mixed number. What button do we have to hit first in order to be able to write a mixed number? What button do we have to hit first, George? The green button. You got to hit that green button first. Then you can hit your fraction button, and that will do your mixed number. So we're going to type in 2 and 4 over 6. What button do we have to hit now to be able to convert it? What button do we hit to convert? The double arrows at the bottom. Double arrows at the bottom. We're going to hit that conversion and hit enter. And there's our decimal, 2.66666. It keeps going and going and going. So we're just going to write 2.66 and 6. The 7 at the end is because your calculator naturally likes to try to round it. Your calculator is a finite tool. It means it has a stopping point. It has to stop eventually. So they're going, well, it keeps going, so we're just going to round it at the very end. But technically, it goes on forever and ever and ever. But your calculator is not going to show that. All right, absolute value. Remember, absolute value is always what? Positive. Absolute value is always positive. So this is technically going to be 2 and 1/3. And let's convert 2 and 1/3. When we convert 2 and 1/3, we're going to get 2.3 repeated. So it's 2.3, 3, and 3. And then we've got a 2.05. Absolute value of 2.05 is also positive, 2.05. But again, I'm going to go ahead and add an imaginary 0 in the back of it. So now we can go ahead and start putting them in order from least to greatest. So least to greatest, I've got 2 negative numbers up here. I have 2 negative numbers up here. So I'm going to focus on those 2 negative numbers first. Here's a negative number, and here's a negative number. Which one of these negative numbers is the smallest? Remember, think opposite with negative numbers. It's an opposite idea. Chris? Negative 1.85. Very good. So we're going to put this number as our smallest value first. Negative 1.85. That means the next number is going to be that negative 1.8. Okay, I'm always going to write them back in their original format. We've now done all of their negative numbers. Let's focus on the positive numbers. Which positive number up here is the smallest? So we've got an 8, a 4, and then we have a whole bunch of these 2s, right? 2 point something. So which one of these 2 point somethings is the smallest? Angel? No. Malia? 2.05, right? The 2.05, the absolute value of 2.05 is the smallest because it's a 2.0. 0 is smaller than 3, it's smaller than the 6. So 2.05, absolute value. We want to put them in their original format. So we're going to write absolute value of 2.05. Always put them back in their original form. Okay, so we've done this one. Now what's the next smallest number? Jeremy? Yep, and we're going to put it back in its original format. Original format was absolute value of negative 2 1/3. Okay, so that means that the last value of 2 point something, that's the 2 4/6, that's the next one that we focus on. All right, from there, we only have 2 numbers left. Which one's the smallest of them? Daniel? The 4.00, right? Or just 4, the original value of 4. And that leaves 8 as our largest, which in original form was 2 to the 3rd power. Good. Always put them back in their original format. So when comparing, it's easiest if you compare them by transferring them into or converting them into decimal first. Convert them into decimals first, and then do your comparisons. So what I want you guys to do is right here, I'm giving you values for how many slices are left over for different types of pizzas. For the pepperoni pizza, we have 2/6 of the pizza left over. For sausage, we have 0.25 of the pizza left over. For the Canadian bacon, we have 4/10 of the pizza left over. And for cheese, we have 3/8 of the pizza is left over. I want you guys to answer these 3 questions about what was left over. Which pizza is the most popular? If it's the most popular, is there going to be a lot left over? No, if it's popular, people ate it, right? So that means there's not much left over. So convert each of these into decimals and figure out which one has the smallest amount left over. That's the most popular. Then for question 2, which one was the least popular? If people didn't like it, is there going to be a lot left over? Yes, right? If you didn't like it, you're probably not going to eat it. So it's going to have the one that's the largest amount of leftovers. And then you're going to put them in order by popularity. Which was the least popular to the most popular pizza? Go ahead and do that one on your own. Okay, pepperoni, 2/6. 2/6 as a decimal. That is 0.3 repeated. 0.3 repeated, which means I could write 3, 3, 3, 3, 3, 3. I keep going. 0.25 is already a decimal, so 0.25. But because I just wrote 3 3s, I'm going to go ahead and put an imaginary 0 behind it. Don't pack up yet. 4/10, that's just going to be 0.4. I'm going to add 2 imaginary zeros behind it. And then 3/8, that's going to be 0.375. All right, so which one has the smallest amount left over? Sausage, right? Sausage has the smallest amount left over. So it's the most popular. Which pizza has the most left over? Okay, the Canadian bacon, which is basically ham. It's like code for ham. All right, and then putting them in order from least to greatest, your smallest one was, or least popular. So least popular would be the one with the most left over. So that's going to be the Canadian bacon is your least popular, followed by your cheese. Then it's pepperoni. And then sausage was the favorite. Okay, if you did not finish your IXLs from yesterday, please make sure you're getting on that and getting it done. You will have some time tomorrow as a warm-up time to be able to work on it. but try and get as much done as you can. And don't forget to work on those graphing things. Make sure you bring it with you, because if we have spare time, you can graph.